Okay, so in the last class, we had a discussion about two things: stationary points and points of inflection. Okay, so let's say this is a curve. So we discussed that this point and this point, they are the stationary points because the derivative here is positive, here it is negative, and at the stationary point it is zero, because that is what the stationary point is, where you get a horizontal line. Okay, and this is negative, then this is zero, and this is positive. So in short, when we had this discussion in the last class, we said that whenever we have a curve and the derivative turns out to be zero at some point, that point is a stationary point. Okay, now that stationary point could be a maximum point, a minimum point, or an inflection point. Okay, so what is the difference in maximum, minimum, and inflection? You know that this is your maximum point. The derivative before this point is positive and after this point is negative. This is your minimum point. The derivative before this point is negative and after this point is positive. So if I talk about the point of inflection, let's say it is something of this type, right? Here, if I make the tangent line, that would also be horizontal. So if we are getting a horizontal line, that means the derivative would be zero here. But what about this point? Here the derivative is negative and here the derivative is also negative. So the fact that the sign of the derivative before and after the point is same is basically telling us that this point is neither the maximum point nor the minimum point. It's the point of inflection. And this is what we discussed in the last class. Okay. Now, obviously, for your exams, you are not supposed to make the drawings and think about things this way. We need some other logic, and only then we can do it. Okay, now I'll tell you. For this thing, we are going to refer to the derivative only. Okay, so to find stationary points, we find dy by dx, we equate that to 0, and we get some values of x. You will see how. Okay, you would have y equals to something, you would derivate that. Whatever you get as the derivative, you need to equate it to 0, and you will solve that equation. That equation would have x only, and that x would basically be the coordinate of the stationary point. Now, as I told you earlier as well, the stationary point could be maximum, it could be minimum, or it could be the point of inflection. So how do we decide that? Okay, for that, we need to talk about the double derivative. Okay, so for that, we have dy by dx. This is the double derivative. Okay, now I'm repeating this one last time. I want all of you to pay attention and listen to me carefully. Okay, in the last class, we had a discussion about stationary points. Stationary point is any point where the derivative is zero. Okay, how do we determine that? Let's say this is a curve. I can see that if I make a tangent line at this point, that is going to be a horizontal line. In case of any horizontal line, the slope is zero. The slope is zero, the derivative would be zero. Whenever the derivative is zero, your that point is your stationary point. This is what we discussed in the last class. Anything that you have not understood about this property of stationary points? Just know you have a curve. Wherever the derivative is zero, that is your stationary point. Okay. Achha, this is clear. Very good. If you know that what exactly the stationary point is, the next thing is the nature of stationary point. The nature could be that the point is a maximum point. How would we describe a maximum point? This is a maximum point. This is a maximum point. Okay, so the stationary point could be a maximum point. It could be a minimum point. It could be a minimum point. It could be a minimum point, that depends. Or it could be the point of inflection. Now, what exactly is point of inflection? This type of a curve. Now, this is not maximum, it's not minimum. Still, the derivative is 0. So we know how to find stationary points by finding the derivative, equating it to 0. And I'll discuss the other steps later on once we do the example. But how to find the nature? This is what I am going to use that. Okay, this is for the nature. This is for maximum. I did not write down the property. I'll write it down. This is for minimum. And this is for the point of inflection. Okay. Now, in case of maximum point, your double derivative is going to be negative. Okay. And in case of minimum point, your double derivative is going to be positive. And in case of inflection point, either the double derivative would be 0 or it won't exist. I'll explain this, don't worry. Or you won't be able to find it. Okay. Acha. Now we know that in order to find the stationary point, I'll give you an example. Let's just rub this and then let's talk about it. Now, obviously, in exam, they're not going to give you curves. It could be that they give you, but obviously they are going to play with the equation. So I'm going to write down a question. So the equation is y equals x cubed minus 12x plus 5. Okay, this is your question. And the question is, find the coordinates of the stationary points on the curve y equals x cubed minus 12x plus 5. So this is your curve. You need to find the stationary points. How do we find the stationary points? Can anyone tell me? Yes, Munja?
We differentiate this one to
Very good.
second derivative. Yeah.
Okay, we will first differentiate and find the first derivative. Okay.
Yeah.
All right. So let me write it down properly. It is minus 5. We need to find dy by dx. That is going to be 3x squared minus 12. And in order to find the stationary points, we will use this property. We know that whatever point it is, the derivative at that point would be 0. So I am going to equate this to 0. And this is my equation. I need to solve this equation. So it would become 3x squared equals 12. X squared equals 4. And x is going to be plus minus 2. So the x coordinates of the stationary point are going to be plus minus 2. What about the y coordinates? Who is going to tell me the y coordinates? Yes.
Substitute x into the first equation.
Very well done. Yes, Haris and Rashal, I want all of you to find the y coordinates for these x coordinates and tell me. Yes, quickly, please, all of you. Yes, Haris and Rashal. What are the y coordinates of this point? Okay, Shal. Yes, Munja, any luck with the answer?
Minus 21
For which x coordinate?
for plus 2.
I think that's for -2, okay?
Okay.
Yeah, so, okay, so the points are -2 and 21. And the other point is 2 and -11. Yes, okay. These are the points. Just check your, yes, Ishal, your answers are correct. The only thing is you have some sign issue with that, but you can check that again. This is the answer actually. Okay. Now, -2 and 21 and 2 and -11, these are the two stationary points on the curve. Okay. Achha, let's do it for the -2 one. Let's say we have this, okay. Y is going to be -2 cubed -12 into -2 -5. -2 cubed is going to give you what? It would be -8 plus 24 minus 5. Okay, so this should be minus, this is minus, oh, okay, my bad. Yes, for this, just give me 1 second. Yes, you guys are right. Basically, I did some mistake in the equation, but that's okay. So it should be -8 and then plus 24 and then -5. That is 11. Yes, you are right. I'm sorry. That is 11. And then this is going to be 8 minus 24 minus 5. This is -21. Yes, this is correct. Yes, Ishal, your answer was correct. I'm sorry. And Munja, yours was also correct. Okay. This is what we have. Okay. Now let's continue the discussion. So this is basically, these are the two stationary points. The next question is you need to determine the nature of these stationary points, that either this point and this point. You have 2 points. You need to use both these points and see if point 1 is maximum, minimum, or point of inflection, if point 2 is maximum, minimum, or point of inflection. Okay. So for this, we are going to take the second derivative, d2y by dx2 equals, this was the first derivative, so this would become 6x. Now, in this equation, I will plug in this x coordinate and this x coordinate, okay? So let's check for -2 and 11. For -2, this is -12. This is negative, okay? Look at this. Whenever the double derivative is negative, the point is your maximum point. This means that -2, 11 is maximum point. And when you will plug in 2, your answer would be 6 into 2. The answer would be 12. That is positive. So that means 2 and -21, this is the minimum point. Right? Yes. Is this okay? Both of you, all of you, in fact?
Yes, ma'am. Thank you.
Okay, you're welcome. What about you, Haris and Ishal? Please confirm if you have understood this or not. Okay, and what about you, Haris? Please answer me quickly. Not the last part. Okay, Haris. Once we have the stationary points, we are going to use this red box to determine the nature. Okay? Pehle you need to find the second derivative. The second derivative is 6x. Okay. Now you will plug in the x coordinates of both your points. First point is minus 211. The other point is 2 minus 21. So first x coordinate is minus 2. Second x coordinate is 2. I plugged in this minus 2 and I got minus 12. The second derivative is less than 0. That means my point is going to be a maximum point. Okay? Minus 211 wala would be maximum point. And then for the minimum point, the derivative should be greater than 0. So the derivative turned out to be greater than 0. And that is why it is the minimum point. Are you okay with this now? Yes, please confirm.
My confusion, ma'am, has always been like saying, where it says due to the second derivative, then our maximum is less than 0.
Oh yeah, I know. Yes. That makes sense. And yes, we have a logic. I'll try explaining that as well. This is through a logic, basically. This is through a logic. So, okay. The thing is that let's just try this, because yes, you are right. And this is how I, remember this for the very first time, that this is opposite. It should have been greater than 0 because that's maximum, but yeah, that is how it is. So let's say this is the maximum point. The derivative here is negative. Sorry, the derivative here is positive and the derivative here is negative. Okay. Now we are talking about the further derivative. The further derivative is basic. Acha, what is going to be the you have not studied mechanics. Are you taking physics?
No.
Okay. All right. This is for y. If I plot a line for dy by dx, that is for the derivative. So it is positive, then it's getting 0, and then it's negative. Okay. This is the sign for derivative. So it would be something of this type. It is positive, then it's 0, and then it is negative. Now study this line. Study this line. What is the derivative of this line? The derivative of this line is negative, obviously, right? Because it is going downwards. Okay. So the derivative of this line would basically be the double derivative.
Yeah.
So that is why it should be less than 0, because it makes sense for this case. I know it is a bit, it looks unrealistic. One might say that it should be greater than 0 because we're talking about the maximum point. But if you look at things this way, things make sense. Okay. So always remember, double derivative is less than 0, then that point would be your maximum point. Okay. It is an opposite relationship. Okay. Right. This is the first example. Let's do another example and then things would get clear. Okay, so I'll write down the question. It says, find the coordinates of stationary points on the curve y equals x square plus 9 by x, and use the second derivative to determine the nature of these points. Okay. Now, what is the question? It says find the coordinates of the stationary points on the curve. Now, whenever you come across the sentence, just know that you need to find the derivative and equate that to 0 for stationary points. Okay. So let's start the working. The solution is going to be, okay. So we need to find dy by dx. But for that, I need to write down y in simpler form. So that would be x squared by x plus 9 into uh, 9 by x. That is okay for now.
Mhm.
Okay. And now I'm going to cancel this and I can write it as x plus 9, x to the power minus 1. And now I can find the derivative dy by dx. That would be 1 minus 9 x to the power minus 2. This is the derivative. And now I need to equate this to 0. So 1 minus 9 by x squared equals 0. I can take LCM. That would be x squared. So I have 1 here. I'll multiply x squared here and with the numerator as well. X squared minus 9 equals 0. I'll take this x squared to that side, it would become 0, and I will get x squared minus 9 equals 0, and that would be x equals plus minus 3. Okay, so I have done this for you. I want you to find the y coordinate quickly, all of you. Yes, please do that quickly. Just find the y coordinates.
Mhm.
Very good. 6 and minus 6. Very good, Haris. So the point is going to be minus 3 and minus 6, and the other point would be 3 and 6. These are the two stationary points. What about the nature of these stationary points? For that, we need to find the double derivative. So I am going to do that here. The double derivative is going to be, yeah, one is positive 6 and the other one is negative 6, Ashal. So here is going to be 0 plus 18 x to the power minus 3. So this is 18 over x cubed. Now we need to plug in the two x coordinates we have. One is minus 3, the other one is 3. When we will plug in minus 3, we are going to get negative second derivative. So 18 divided by minus 3 cubed would basically give you 18 divided by minus 27. That would be 2 by 3. It is negative 2 by 3. So negative 2 by 3 means it is less than 0. When second derivative is less than 0, I told you it has an opposite relationship. It is going to be the maximum point. So this is going to be the maximum point, and this is going to be the minimum point. You can check for 3, right? Any doubts about this? All of you, anything that you have not understood, please tell me. Okay, what about you, Haris and Munja? Please tell me if you have understood this or not.
Oh, yes, ma'am. Thank you.
Okay. All right. I'm going to clear this. Okay. The next thing is we are going to talk about rate of change. Okay. So if you come across the term, find the rate of change of V, find the rate of change of H, find the rate of change of anything, that is just this, that you need to differentiate that variable with respect to time. So I'll write down a question and then you would understand it easily. Given that H is 1 by 5 t squared, find the rate of change of H with respect to t when t is 2. Now it's very easy, only the wording is different. Find the rate of change of H. So rate basically means anything divided by time, okay? So this means you need to find dH by dt. You need to derive H with respect to t. So that would give you, this is the equation, it would become 2 by 5 t. And you need to find it when t is 2. So plug in 2 and that is going to give you 4 by 5. So this is going to be the answer for this, right? Any doubts about it? Okay. Let me see if I have some other example before going to the next chapter. Okay, so we'll do more practice once we start doing the past paper questions. Okay, for now we are done with differentiation and now we are going to start the next chapter, integration. So anything, any doubts in differentiation, any topic that you want me to do again, please tell me. Because now I can give you the quiz. I did not send the quiz yesterday because obviously every other question was related to this, this chapter for the differentiation.
For me, the functions, ma'am, unless I mean, you mean something different.
Yeah,
I said the
functions.
only.
Yeah, you told me functions. Yeah, you told me functions earlier as well. Don't worry, we'll do that. I'll share the recordings with you. But like for now, I'm just asking for differentiation because that is a difficult chapter. At least this is
Okay,
the
sorry.
thing. So no, that's okay. So any doubts in that? Okay. I guess that is okay. And obviously, at the moment, you guys need to revise that again, and only then it would be that if you have some questions, you can ask me later on. For now, let's just start doing integration. That is the last chapter of pure maths, okay? So let's do it. It is chapter number 9. Integration. Okay. Now, what exactly is integration? I would not, waste too much time. I'll just write down a formula and then that is it. Integration is basically the opposite of differentiation. Okay. Now, let's say you have a function and you are interested in integrating it. So let's say it is y equals x to the power n. How do we integrate anything? This is the symbol. This is how you write down the function. You need to integrate it with respect to x. And how do we do it? So we write down the variable as it is. We write down the old power. We add 1 to the old power. We divide it by the new power plus c. C is just a constant, okay? C is just a constant. Okay. Now, this is basically a symbol for integration. Just like for differentiation, we used to write dy by dx. For integration, we write down this sign and we write down dx. How exactly we integrate? For integrating, we write down the variable, we write down the old power, we add 1. Now n plus 1 is new power. We divide it by new power and we add the constant. This is how you integrate it. Any doubts about it? Yes. Any confusions in the formula at least? Okay. All right. Good. Now this is just a formula. Now what exactly is the logic of integration? So for differentiation, I told you it is the derivative, it is the slope, it is the value of the gradient at any point. For straight lines, it's same. For curves, it keeps on changing. Integration gives you the area under the curve. For example, this is the y-axis, this is the x-axis. Let's say this is a curve, okay? So this point is A, this point is B, and let's say it is y equals f of x. In order to find this area that is under the curve, what am I going to do? I am going to integrate the function f of x with respect to x, and the limits are going to be a and b. Initially, I did not talk about the limits. Now this integral is without limits. I don't have any number or anything written here and here, right? That's okay. You'll see both the cases. We'll study how to integrate both of them. But just the logic of integration is that whenever you are integrating a curve, you get the area under the curve, right? It's just the logic. But now, even if you have not understood this, that's okay. I just wanted to give you an idea about what exactly integration gives us. Okay. The next and the most important thing is whenever you are going to integrate your derivative with respect to x, what are we going to get? We are going to get the original function plus c, okay? So basically, how do we differentiate? Let's say I have y equals x, okay? Now when I will differentiate y equals x, or let's say y equals x square. So dy by dx is the derivative, that is 2x. Now this is the derivative, okay? Now I'm saying when I will integrate this 2x. Let's integrate this 2x with respect to x. That would give me 2x as it is. The old power was 1. I'll do 1 plus 1 divided by 2. 2 and 2 cancel, plus c. So what is this? This is x squared. This is the original function. The only thing I want you to understand is that whenever you are integrating the derivative of a function, you will get that function plus constant. Okay, you'll get that function plus constant. Any doubts about this, Haris, Ishal, and Munja?
No, ma'am. Thank you.
Okay, and what about the other students? Yes, it is the reverse basically. Okay. All right, very good. Now let's do 2 to 3 practice questions, and then that is it for today. Okay. So we need practice for this. Right, so they want you to find y in terms of x, okay? The statement is find y in terms of x. First question is dy by dx equals 1 by x squared. The second one is dy by dx is x under root x. And then the third one is f dash of x equals 4x cubed minus 2 over x squared plus 4. Okay, we have 3 questions. I'll just stop this. Okay, you need to find y in terms of x. Basically, the question is to find the original equation of the curve whose derivatives are these. Okay, dy by dx equals 1 by x squared, and then we have 2 other examples. Okay, what exactly is the question? You need to find the equation of the original curve whose derivative is 1 by x squared. So we know that if we are going to integrate f dash of x with respect to x, that gives us f of x. Similarly, if we are going to integrate dy by dx with respect to x, you will get y plus c, right? The only thing I want you to understand is whenever you are differentiating your derivative, you will get the original curve. Okay, this is the question. They want you to find the original curve. So for that, you will integrate this derivative. So you know that the integration of dy by dx with respect to x gives you y. So you will integrate this 1 by x squared with respect to x. We don't know how to integrate any x in the denominator, so we'll take x in the numerator. This is what we have. Now we have x to the power minus 2. So in order to integrate it, we will write that down as it is. Okay. So we are going to write it down minus 2 plus 1s divided by the new power plus c, and the answer is going to be pi equals minus 1 by x plus c. This is your original curve. Now you can see, if you will differentiate this curve, you are going to get 1 over x squared, right? Is this okay? Any doubts about it? Yes, Haris and Ashal. Munja, please confirm.
Thank you, ma'am. I think it's clear.
Okay. Then the next two questions are for your homework. You can try doing them on your own. You know how to integrate. You need to first simplify the function, whatever it is. Okay. Once you have a simplified function, by simplified function, I mean you have x with a power and that x is in the numerator. You are going to add 1 and divide that by new power. Okay. So that's it for today. Then we will continue integration tomorrow and let's see if you guys are able to do it or not. For now, you need to do the second question and this third question and send it to me. Okay. I'll be waiting for your homework. So I want all of you to try these two questions. Okay.